So I did question 35 from chapter 13, and it reads that a satellite of mass 200 kilograms is placed in Earth orbit at a height of 200 kilometers above the surface. For part A, assuming a circular orbit, how long does the satellite take to complete one orbit? For part B, what is the satellite's speed? For part C, starting from the satellite on Earth's surface, what is the minimum energy input necessary to place the satellite in orbit? Ignore air resistance, but include the effect of the planet's daily rotation. So to start question number 35, I drew my diagram. There you have the Earth, the satellite, and this is just some information that you need to know for the problem, how far the satellite away is from Earth, the radius of the Earth, the mass of Earth, and then there's G and the mass of the satellite. So I actually did part B first because by finding the speed, you can take that velocity and then find the period, which is what you're looking for in part A. So for part B, which is what I did first, you just take Newton's law and F equals ma, but since the orbit is circular, A becomes V squared over R. So then I just plugged in some things. So it's the force of gravity times, the mass of the satellite, and it's circular with its circular acceleration. So then you're trying to find V, and then you plug everything in, and then V equals 7,787.5 meters per second. So now that you know the velocity or the speed of the satellite, you can find the period. So the equation we know for the period is 2 pi over omega. We don't know omega, but we know that omega is velocity over r. So that means we know that the period is 2 pi r over v. So then with that, we can plug in what we know and then get the period being 5,308 seconds. So for part C, we need to find the energy input to place the satellite into orbit. So we just take the initial kinetic energy, the initial potential energy, the energy input, and that's going to equal kinetic energy final and then potential energy final. So I rearranged the equation to get E by itself, and I just went ahead and substituted for the kinetic energy final minus kinetic energy initial plus the potential energy final minus potential energy initial. And then I went ahead and substituted. So the only difference is for V velocity, that's the velocity of the Earth, and so you just replace that with, you actually use the same equation from up here, but you just find V instead, so that's why it becomes 2 pi r over t, and the period for the Earth is 86,400 seconds, which is how many seconds there are in one day. And then you can get those from up there, and then you get the energy to put the satellite into orbit being 6.43 times 10 to the 9th joules.